All right, let's go to this one right here. Analyze the following function and determine the zeros and state any multiplicity that they might have. All right, so what that means is the following. This is already in what we call factored form. But if I were to multiply this out, if I multiplied the x times, well, x squared means x times x, then you would have an x being multiplied times an x being multiplied by an x squared, which if you do the math, that's going to be x to the fourth power, right? There's an x being multiplied by an x multiplied by an x squared. That's x to the fourth power. So if you actually multiplied this out, you would have x to the fourth and some other, like a lot of terms after that, like 3 more terms possibly, or 4 more terms after that. But I don't want you to multiply it. All I need you to know is the leading term would be positive x to the fourth power, and there would be some more terms. So that means that this thing is going to go up, is going to cross, 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 and cross. It's got to end up and up, because if it's a positive x to the fourth, it's going to end up and up, like I mentioned on the earlier expression. The other thing is, because it's got 4, then it probably has at most 4 zeros. At most 4 zeros. Now, if you pay close attention, since this is factored already, I think I can get a better picture of this. All right, what this is, this x is by itself, so if you solve for 0, x equals 0. If you solve for x here and solve for the 0 there, x plus 4 equals 0, so x equals negative 4, right? The opposite. So somewhere over here at negative 4, it crosses there. And here, it's, if you solve for x in there, it's x equals 1. But see that exponent of 2? That basically means that you have x minus 1 and another x minus 1, which means you get x equals to 1 2 times. All right, what that means here is right here. Let's say this is 1 right here. There's 0 right there. There's negative 4 right there. I know the function has to point up. So the graph is going to go down like this. Okay? It's going to go crossing negative 4. And then it's also going to cross. I don't know how far down it's going to go, but it's going to go downward. It's going to go up. And then if it goes down, it's going to violate. Wait a minute, it can't be going downward because it's supposed to go up and up, right? Well, the thing is that whenever you have an exponent of 2 or 4 or 6, when you have an even numbered exponent on a 0, that even exponent, that basically means that it kind of acts parabolic at that shape, at that place. So it's gonna like be like a parabola right here with a vertex there, and then it's gonna go up. So that's the way the graph is gonna look. Now you can verify it, we can do it in class, but if it crosses the 0 once or 3 times, like an odd number of times, it's gonna cross. So right here, x equals 0, since there was only one answer there, it only crosses here once. On the next one, negative 4, let's say it's over here, because there's only one negative 4 answer, it's going to cross through there. But right there on that last one, right here, because it crosses an even number of times, and twice in this case, that means that at positive 1, there's going to be a, again, like a parabolic shape. I knew that the end behavior was up, and I knew that the end behavior was up over here as well. So my graph had to look like it crossed, and then it touches, and then it goes up. The official word for when it touches is called tangent. It is tangent at that particular place. So I don't know, I mean, this is an ugly graph, but I know that if you graph it, you're going to have some sort of picture like that. Oops, sorry. Some sort of picture like that, where it crosses here, it crosses there, it comes back here, and it goes back up like that. Again, that's an ugly picture, but I can tell you without looking at a graphing calculator that that's the way the graph is going to look. So when we analyze the graph, that's what we want you to do. You're going to say the end behavior is the following. If I ask you about end behavior, you'll say the limit of f of x as x goes to negative infinity is infinity. The limit of f of x as x goes to positive infinity is also infinity. Like, that's the end behavior. we can say that the zeros of the function are at x equals -4, 0, and 1. And specifically at 1, there is a multiplicity of 2, meaning that answer 1 is there multiple times. The exponent tells you that it's there twice. Okay, so that is what I mean by analyzing the graph. And then you can graph it as well and so forth. But depending on what we ask you, you're going to answer. If I ask you about end behavior, you answer the end behavior question. If I ask you about the zeros, you answer about the zeros. If I tell you to make a sketch of the graph without using a graphing calculator, then you make a quick sketch of that graph. So that's how you're going to analyze the graph based on what we're learning. It all makes sense, guys, by the way. So this one is let's go to letter B now. So on letter B, we have a cubic function, and it's positive. So I know for a fact that it's going to go down here and it's going to go up right there, like a regular cubic function, right? The only thing is I notice that because it's got other terms and it's got a 3, I'm thinking it's going to cross once, twice, 3 times. I'm thinking it's going to have 3 zeros. 1, 2, 3 right there. Now, I know the end behavior already, so I don't have to, if all they ask me is about end behavior, I already know. The limit of f of x as x goes to, well, I'll write it down. The limit of f of x as x goes to negative infinity is going to be, let's see on the left side, it would be negative infinity. The limit of f of x, and again, remember I'm going pretty fast. You guys can pause, rewind, fast forward as needed. That would be the end behavior right there. Now, if I wanted to, if they ask me about the number of possible zeros, you'd say, oh, number of possible zeros, 3. Number of possible turning points, 2, like 1 less. If they ask me to find the zeros, now you have to do some math. So here it says determine the zeros, so I'm going to have to do this. So what I'm going to do is I'm looking at this expression and I notice that they're all divisible by 3, and also they all have x's. So you factor out a 3 and an x, and that's going to leave you with x squared minus x minus 12. Again, if you distribute back, you'll see, we can talk about that in class, but we did that week 1 of our school year, and you did that in algebra 2. 3x times x squared, 3x cubed. Okay, let me do the pointer here. 3x times x squared is x cubed. 3x times negative x is negative 3x squared. 3x times negative 12 is negative 36x. All right, so then you factor this some more. And again, I hope you're good with the FOIL method. X times x, negative, positive times negative, negative. And you have to put a 3 here and a 4 there, because that's what's going to give you that product. And at that point, I'm ready to solve. Set this equal to 0, and you divide by 3, x equals 0. Set this equal to 0, move the 3 to the other side, x equals negative 3. Set this equal to 0, solve for x, move over to the other side, x equals positive 4. So the zeros are x equals 2, negative 3, 0, and 4. So as I said before, this thing would cross negative 3, 0, and 4. I knew that it was a cubic function, so I knew it was going to cross, and then cross back up here. Again, these are not perfect graphs, and I'm trying to rush so I don't make this video too long, but that's the way the graph would look if in case I want you to make a sketch of the graph based on that. Alright guys, there's about 22 minutes. Well, I guess let's do one more, might as well, right? So I'm going to go ahead and do the last one, and it's going to be the same thing. Looks like I'm at about 22 minutes, so I'm going to go ahead and try to end this one soon here. This one right here, look at the biggest degree. If you look at it, it's already this one. It's cubic, so it's pretty much the same as this one. If I want to find the zeros, I say, okay, what do they all have in common? They all have a 2 that I can divide out, and they all have an x that I can divide out. So you divide it out, you undistribute the 2x, and what's going to leave behind is x squared minus 10x plus 25. Once again, you can always double check your work by redistributing. 2x times x squared is 2x cubed, right? 2x times x squared is 2x cubed. 2x times negative 10 is negative 20x squared. 2x times 25 is 50x. So that does work. That is the fact.